Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, the 2012 sample question on probability looked at conditional probability and independent events. So the question read, the events A and B are such that the probability of A is equal to 0.7, the probability of B is equal to 0.5, and the probability of A intersection B is equal to 0.3. Find A union B. Okay, well, there's a formula for it that states that the probability of A union B is equal to the probability of A plus the probability of B minus the intersection. Okay, so the probability of A is 0.7, the probability of B is 0.5 minus the probability of the intersection. That's 1.12 minus 0.3 is 0.9. Right, okay. So a couple of things. That's all fine and well when you know your formula. What happens if you don't? Okay, well, for example, if you had written this out, so the probability, because you knew that union was the two added together, okay, you might have got 0.7 plus 0.5 to give you 1.2. Okay, there's your first flag. You can never have probability greater than 1 because a probability equal to 1 as percentage is 100%. So if you're 100% certain of something happening, then you're fully sure. You can't have 120% certainty. So you can never have probability greater than 1. So when this happens, chances are you haven't subtracted off the intersection. Okay, that intersection is counted as part of A and part of B. Okay, so that's why we have to subtract it off once, because we've counted it twice here in A and B. Okay, what I find easier is actually to draw a little Venn diagram of the event. Okay, and nothing's stopping you doing this either if this is the way your brain thinks. Okay, so there's my A, there's my B. So the intersection always goes in the middle. Of course, I didn't give myself enough room, so 0.3. Probability of A, well, the whole thing there is A. Okay, so if A is 0.7, then 0.4 of it is out here, plus the 0.3 that's in the middle. So there's my total 0.7. In the same way, probability of B is 0.5. If 0.3 of it is here in the middle because it's common to A and B, then 0.2 of it belongs to just B. So there's my 0.5. So then it's easy to see that when you add them up, then it's 0.4 plus 0.3 plus 0.2 to give you the 0.9. So maybe that's an easier way for you to work it. It doesn't matter. It depends whether you're a formula person or not a formula person. Okay, so that's part A. Part B then is find the probability of A not B, okay, or A given B has occurred. So this is, again, formula. The probability of A given B has occurred is the probability of the intersection over the probability that B has occurred. Okay, let me see if I can give it to you visually. The probability of A given B has occurred. Okay, so given B has occurred. So you're in this circle here. Okay, so that's given B has occurred here. Okay, and that's why you divide by the probability of B. Okay, then the probability of A, can you see when I do that, that the only bit that belongs to A is that 0.3. Okay, so this is the probability of A given B has occurred. Okay, so the fact that B has occurred literally means this part is eliminated. We're only looking at B has occurred. Okay, now the probability of A, well, that's the part there that belonged to A. So that's why the intersection goes on the top, given just B has occurred. Okay, so maybe that will help you as a visualizer of what is happening in conditional probability. So it's 0.3 over 0.5, which is 3/5, which is 0.6. Okay, state whether A and B are independent events and justify your answer. Okay, there are 3 formulas for independent events that I don't know off the top of my head. I only know one. Okay, so I've just got the book here in front of me. So I'm just flicking to independent events to find the 3. Okay, I have them here now. So the 3 events are the probability that the probability of A given B has occurred is just equal to the probability of A. Okay. In other words, if they're independent, the fact that B has occurred has no bearing at all on whether A has occurred. Okay. The second formula, the probability that B has occurred, the probability of B given A has occurred is just the probability of B. Okay. And then the third one is the one that I knew, the probability of A intersection B is the probability of A by the probability of B. Okay, where did this one come from? I suppose it's probably the hardest one to see where this one comes from. Well, actually it comes from this formula here. So the probability of A given B is the probability of A intersection B over the probability of B. Okay, so this isn't part of the answer, it's just only working it out. So this part here, I'm going to bring up here. Okay, so the probability of B by the probability of A given B is the probability of the intersection. Okay, now remember, if they're independent events, the probability of A given B is the same as A. So it's the probability of B by the probability of A is the intersection. So you can see they all come from conditional probability, and that makes sense because remember what the definition of independent events are. The outcome of one event has no bearing on the outcome of the next event. And that's what conditional means, okay? Conditional means the probability of an event given another event has occurred. So yes, there's 3 formulas, but they all stem from conditional. Okay, which one you use doesn't matter at all. It's which one do you have the information to use. Okay, so we know that the probability of A given B is 0.6. Let's see, is it equal to the probability of A, for example? Okay, so let's try this one. Well, is 0.6 equal to the probability of A 0.7? That was easy, not independent events. Okay, so you'd write out your formula, you'd write out the values as such, and therefore state that they're not independent events. Okay, we haven't worked out the probability of B given A. It wouldn't be that hard. Let's try this one. The probability of the intersection 0.3, is that equal to the probability of A 0.7 by 0.5? Well, 7 5s are 35. They're not equal, so again, not independent events. So you only need to do it for one formula, but it does kind of come down to what information do you have to be able to check for independent events. This is the information you normally have, which is probably why it's the one I tend to default to. But you know what? Look how easy that one was if you know these formulas. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.